This is my first video for you guys. Finally figured out how to get good audio and to show you my presentation that I have uploaded on Canvas, and it will look good for you. So today on Monday we're going to be talking about quadrilaterals. And you should have seen quadrilaterals last week as far as identifying what kind of polygon it is. So if we move on, our learning target today is I can connect characteristics of different polygons. And our target practice is I can identify quadrilaterals by their sides and angles. So this is the main thing that we're doing today. So, all right, we're going to go through some math vocabulary. Last week, you should know that polygons are closed plane figures. So usually what we call this is we call them shapes, okay? Shapes is pretty typical of what we know as closed plane figures. And but overall, that word that we're trying to look at is polygons. Anytime I'm talking about polygons, I'm talking about shapes, and I'm talking about closed plane figures. Now, plane figures is what the Moby Max assignment last week was called. And I know that's a lot of different vocabulary for the same thing, I know. But overall, you should know that it's shapes. So polygons are formed by 3 or more line segments. So the smallest polygon we can have is 3, which is a triangle. And they meet at these points called vertices, and we know that vertices from last week are at the end or at the tips of these shapes are the polygons. It's named by the number of sides and angles it has. So triangle is 3. So there's 3 angles, 3 sides, 3 vertices. Same thing with the square. Okay, square, this is a quadrilateral. That's what we're going to be talking about today. It means 4. And there's lots of different types of quadrilaterals, and that's why there's a whole lesson dedicated to quadrilaterals. But yep, 4 sides, 4 angles, and 4 vertices. So, yep, quadrilaterals, 4-sided polygon. Same thing that I was just talking about. So we're going to move on. Angles. Actually, I want to go back. I'm going to talk about polygons because this is kind of interesting. So poly means many in Latin, and the part of the gon part, if you look it up, there's different definitions of gon, but gon actually comes from the word that means like elbows. It's either elbows or knees. So it's really like they describe shapes from the human, like a human form, which is like elbows. So like our elbows bend at an angle, so do our knees. So it's kind of funny that way. But I want to move on. Sorry, I thought that was kind of cool to say. Angles. So last week, guys looked at types of angles. Acute, right, and obtuse. That's the only angles that we're going to be dealing with today. There's other angles, but when it comes down to polygons, these are the 3 that you're going to be using. So acute angles is an angle less than 90 degrees. A right angle is an angle exactly at 90 degrees. We're also going to be talking about perpendicular lines or sides. And then we're going to look at obtuse angles, which is more than, it measures between 90 and 180 degrees. Unfortunately, I'm not going to have you measure angles. That's kind of something that's limited with online learning. However, I do have lots of interactive websites on my Saturday part of my module. You can click on it, and it's a bunch of interactive sites. There's like 2 or 3, I'm pretty sure it's 2, interactive websites that you can click on that helps you like measure angles and know how to do that. But for this, it's going to at least tell you what the angle is, or you're going to just look at it and know that it's going to be less than or more than 90 degrees. So today it's really important that you understand these new vocabulary, parallel lines and perpendicular lines. Parallel lines are lines that are never touching, and they're the same distance apart. And so we're going to be looking at shapes that basically have parallel lines and opposite ends of each other. And that's going to be really important in this lesson. So these are parallel. They're never going to touch, okay? And then these are parallel, okay? They're never going to touch. And so anytime we're talking about parallel lines, we're talking about the opposite, like across from each other. Perpendicular lines are important today as well. You're going to know that perpendicular lines are lines that intersect to form a right angle. So anytime you see this, you know it's a right angle because it has a square. And squares, by definition, have 4 perpendicular lines or 4 right angles. And so we're going to dive in. Okay, here is the Unlock the Problem lesson on lesson 11.3 for quadrilaterals in your Go Math textbook. A seating chart for a baseball field has many four-sided figures, or quadrilaterals. What type of quadrilaterals can you find in the seating chart? So you'll be able to answer this question after we learn what is a quadrilateral, what are types of quadrilaterals, what are some of the properties that they have. And then we're going to go into how do we organize them in a family. And that gets a little complicated, but we'll get there eventually. So quadrilaterals, we know that they're four-sided figures, but there's 5 quadrilaterals that we're going to be talking about today. Only 5. There's more than 5, but we're just going to be talking about the 5 that they have in the textbook. And so, again, we're going to be looking at parallel and perpendicular lines. All right, we know that parallel lines are on the same distance apart and never touch. And we know that perpendicular lines are lines that intersect that form a right angle. And you should have seen these types of angles, or at least the right angle, when you see let me see if I can draw this. Oh, no, that looks like an equilateral triangle. Oh, no, that's not a race. Okay. One more time. See if I get it. There we go. This is a right triangle. Oops. There we go. It usually looks like that. And it has a right angle. So it would have a perpendicular line that intersects at a 90-degree angle. So, moving on, there's 5 types of quadrilaterals you're going to be looking at. So we know generally that a quadrilateral, right here, 4 sides, 4 angles. But we're going to look at a trapezoid. A trapezoid is a quadrilateral with at least one pair of parallel lines. One pair of parallel lines, and they're right here. These are not parallel. Do you see how this one comes at an angle right here? Not parallel. So, you can see a trapezoid like that, but you can also see a trapezoid like this, where it's like that. Ooh, nope. Nope, it's going to keep making it a square. Okay, that's all right. you'll see the type of or trapezoid in a second. So a parallelogram is a special trapezoid. Now this is really important. It's a special trapezoid with the opposite sides, and these are opposite sides right here, that are the same length and are parallel. Okay, so these are the same length. Okay, if we were to measure it with a ruler, it's the same length. Same thing here. These are the same length and they're parallel. But you're going to notice that these aren't the same length. So if you were to compare a red side to a blue side, it's not parallel. So you can't have a triangle, not a triangle, a parallelogram that looks like that. I know that looks really weird. Let me see if I can make this a little better. So you could have like parallel sides. Oops. Little side, big side, and then they're going like that. That's not a parallelogram. A rhombus is a special parallelogram, and do you notice how it's going in order? So it's a trapezoid. It goes basically quadrilateral, trapezoid, and this is a special trapezoid. Now we're kind of moving into parallelograms. Okay, so rhombus is a parallelogram. It's a special parallelogram with 4 sides with the same length. All of it is the same length. So something that I kind of didn't go into last week was that like these lines right here on the sides, and I can kind of do this right here. These one-liners right here are telling me that they're all the same. They're the same length. Okay? And I'm going to move down and I'll compare this to a rectangle. Right here is that there's only one line. This tells me that these are the same. And then these 2 lines are telling me that these are the same. That's something that I didn't make clear last week that I'm hoping that I can clear up this week. These are right angles. But you're going to see in like even in this, parallelogram, you're going to notice that the way that we measure these is like this, with like a little swoop right here. Okay, that's where we take what am I forgetting what it's called? A compass, and we measure the angle. So let me just get out of this. Let's talk about a rhombus. So a rhombus is a special parallelogram with 4 sides with the same length and and it has parallel sides. So we know that it has parallel sides, and I'm not thinking of a compass. I'm thinking of a protractor, I think. Yes, I always get those 2 mixed up. You have to use both to create shapes. Yes, but a protractor. Okay. A rectangle is a special parallelogram with 4 right angles and 4 perpendicular lines. And that's where these right angles come in. So these rectangles, and we're going to go into a square, these 4 right angles are extremely important. That's what differentiates it from a rhombus. And it has 1, 2, right here, the 2 pairs of parallel sides. Okay, and then we're going to go into a square. It's still a special parallelogram with 4 sides with the same length. That's where that pink lines come in. And also, guys, these lines, remember, these lines tell it's all the same. And then 4 right angles right here. 4 right angles. And remember, guys, you can fast forward, go back in this video. That's what's kind of nice. And kind of look back at this. Okay, this is where it gets kind of funky, because a lot of these definitions kind of run into each other. There's multiple parallelograms, and if a parallelogram is a trapezoid, then all of these are trapezoids technically, right, by that definition. And all of these shapes are quadrilaterals, and so that's what this is at. Okay, excuse me. We know that a quadrilateral has 4 sides and 4 angles, right? All of these shapes in here have 4 sides and 4 angles. Since we know that a trapezoid is a parallelogram, this parallelogram is going to go into this trapezoid. And this is just a diagram to help you navigate whether one shape is the other. So this parallelogram encompasses a rectangle and a rhombus. Okay, we know that parallelograms must have 2 pairs of parallel sides. There are 2 pairs. Okay, this is a pair of a parallel side. This is a pair of parallel side. Same thing here. 1, and then here. And so, in order for it to be different, a rhombus from a rectangle is that a rectangle doesn't have to have 4 equal sides. It just needs to have 4 right angles. That's what makes it a rectangle. And then a rhombus just needs to have 4 equal sides. The angles here can change to be whatever, These are obtuse angles, and these are acute angles, but it can go up, 5 degrees, which would change the whole thing, but it's pretty, relaxed. Like, you can have lots of different types of rhombuses as long as it has the same length. And you can have all different types of rectangles. You can stretch, this out, or you can have even a smaller rectangle. That kind of look like a square, but there's only one way to make a square, right? It has to have 4 equal sides and 4 right angles, which combines these 2 definitions of a rectangle and a rhombus: 4 equal sides and 4 right angles. And that's about it. So when you are given a shape, whether it be a square, you can say, well, a square is both a rectangle and rhombus, and a parallelogram, and a trapezoid. So the square is in all of them. It's in a rectangle, rhombus, parallelogram, and a trapezoid when you start to identify quadrilaterals. And so, if we move on, you guys can listen to the song. It talks about all 5 of those shapes. It also kind of talks about, and this happened in the other videos, it talks about adding up all of the angles, and it equals either 180, 520, 360, any of that kind of stuff. We're not going to go into that, but that is a property of quadrilaterals. We know that when we add up all the angles, it's going to all quadrilaterals are going to equal, I think it's 540. But we know that all triangles, if we add up all of their angles, is going to equal 180. And so that's something extra, and I'm sure in 6th grade you guys are going to talk about that. Okay, baseball seating chart. Okay, so what types of quadrilaterals can we find in the seating chart? I kind of circled some for you, but you guys can go ahead and name these on your own. I'm not going to tell you. but you'll be able to identify what kind of quadrilaterals they are based on what we just learned. Okay, so we're going to go ahead and keep talking about the quadrilateral family with the definition of the trapezoid being one pair of parallel sides. Sorry, this should be actually, I should have changed this, but I didn't, and that's okay. Oops, okay. This definition says at least, and words are funny because one word could change everything. At least one pair of parallel sides. And you're going to run into a different definition, and it's on a different slide, so we'll get to it. But this is what we know. We know that a rhombus is always going to be a parallelogram. We know it's always going to be a parallelogram because the rhombus in the diagram is in the parallelogram. Okay, and by definition, we'll always have two pairs of parallel sides. And a parallelogram is always going to be a trapezoid because the parallelogram is in the trapezoid's definition of at least one pair of parallel side because the parallelogram has two. So it has at least one, right? A square is always going to be a rhombus, okay, because a square is in this diagram right here. And then a square is always going to be a rectangle because it's in the rectangle right here, okay? All right, a rhombus is sometimes a square, right? Because a rhombus, so a rhombus is sometimes a square. So it's kind of going in the opposite direction. But a rhombus could also just be a rhombus, which is like four right angles, or anywhere in between those angles that it can change into. A parallelogram is sometimes going to be a rectangle because there's two other types of parallelograms in the diagram. It can also sometimes be a rhombus or a square, right? There's three types of parallelograms within in the diagram. A trapezoid is sometimes a parallelogram, right? But a trapezoid could also, depending on the definition, just be a trapezoid, and then this one's going to, that one's going to be just kind of depending. And then a rectangle is sometimes a square, right? A rectangle can become a square by having all the same equal sides, right? Congruent sides. And so it gets complicated, guys. And I don't want to make it too complicated, but you can always go back to this diagram when you are doing anything on Think Central. But I don't want to add a whole nother layer of complicated. But I want you to go ahead and do the student practice, classify the quadrilaterals in many ways as possible. Okay, so this right here, even though it's a square, I know it's a square because it has four equal sides, four right angles. It's a bunch of other stuff too. It's a rhombus, it's a rectangle, it's a parallelogram, it's a trapezoid, it's a quadrilateral. If you just kind of go up the scale, we will start here. We start here, and then we can kind of branch out. Go to rhombus, we can go to rectangle, we can go here, and then here. These are all the labels. Because the squares and everything is going to be named everything. Just in this. Okay. We're going to talk about the definition of a trapezoid because this part's really important. There are two definitions for a trapezoid. Okay. There's the Go Math definition, and then there's a Khan Academy definition. Now, since there are, in the math community, there's two camps of thought. A trapezoid's either at least one pair of parallel sides, or it's exactly one pair of parallel sides. Now, in the Go Math version, I've showed you this already, this is what the quadrilateral family would look like. The trapezoid would be in like the parallelogram, rectangle, rhombus, square and parallelogram would be all in the trapezoid, because trapezoid definition says at least one pair of parallel sides. Now, here in the Khan Academy version, a parallelogram isn't a trapezoid. They're separate, because if a trapezoid's definition is exactly one pair of parallel sides, a parallelogram, you need at least two, or you must have two parallel sides in order for it to be a parallelogram. So that can be kind of confusing. I just know for sure for our test on Friday, we're going to use the Go Math version of the trapezoid definition, just because that is our district curriculum and I don't want to kind of stray from that. But just know, I don't know, when you get older, there are two definitions of a trapezoid. And I did assign a video that kind of explains that. And I mean, it's just another guy saying there's two definitions. But maybe hearing it twice will help you kind of absorb that information, because it can be confusing. I understand that. Especially if you're going to go into, and we already did this, but in your student practice, is that you're like, okay, like technically in the Khan Academy version of a square is not a trapezoid. So this right here wouldn't exist in the Khan Academy version of a trapezoid. So you just got to be careful about that. But we are going to use the Go Math version for this. So please include trapezoid if, and any shape that I give you is going to be at least a quadrilateral and trapezoid in a parallelogram anyways. You just have to determine whether it's a rectangle, rhombus, or square. Yeah. Okay. So, that's about it. Let me see. Let me get out. There you go. You do have Think Central homework to do. Please do it. And you have to do it because it counts for attendance. So even though the practice isn't being graded, because I don't grade, practice work usually, you have to go ahead and just do the homework, okay? So you can get attendance for that day. Now, that being said, last week, you probably still have homework from last week that you didn't do, maybe, right? If you're going on to Think Central and you know exactly what I'm talking about, you don't have to worry about this. It's just for the students who maybe read, this is not going to be graded on the directions, decide not to do it. I don't know. Aren't getting attendance for that day, because I don't know for sure if you've gone through the PowerPoint, right? Unless I have I don't know. It doesn't, there's not really a part of Canvas that can tell me that you've gone through this PowerPoint. So I don't know. Just let me know. If you need help getting on there, if you have any questions. Yeah. Well, that is my lesson. Woohoo! I got through one video recording lesson. So if you have any questions or concerns, just let me know.